The topic is double integrals over a general region. So let's do this example. Evaluate the double integral over d of e to the x minus y dA, where d is the triangle with the vertices 0, 0, 1, 3, and 2, 1. So first, let's draw our region. 0, 0 will be right there. 1, 3 will be this point. And 2, 1 will be this one. So the triangle is, let's draw the triangle. Alright, now we have two options. We're either gonna use type 1 or type 2 region. So which one we want to do? Let's try to do type 1. Well, let's try to do both of them, and then we just evaluate one integral. Alright, so let's start with type 1. Type 1, we want the dx to go from a to b. Yeah, the problem we have here, and then you want the y. See, if you notice, y goes from g1 of x to g2 of x. In other words, it goes from this function to this function, the one upper. But here we have a problem. In the bottom, we have one function, but on the top, we have two. We have this one, and we have this function. So the smartest way to do it is divide this in half, and instead of calling the whole thing R, we're going to call the first one, or D. So let's call this D1, and this will be region D2. So in other words, let's call the problem example 1. So in other words, 1 will be equal double integral of ex minus y dA over R1 plus double integral over R2 of ex minus y dA. Alright, what's next? So next we need to find the equation of these functions. So the slope for this one, the slope will be, let me do it here, the slope will be 3 minus 0 over 1 minus 0, 3 minus 0 over 1 minus 0, which is equal 3. Y-intercept is 0, so basically y equal mx plus b, which is 3x plus 0, so it's 3x. So that's the equation of that piece of line. Now what about this one? M will be equal to 3 minus 1 over 1 minus 2, which is equal to 2 over negative 1 and negative 2. So y minus 3 will be equal to negative 2x minus 1. I'm trying to find the equation. So y will be negative 2x plus 2 plus 3 will be plus 5. We're going to need also, where do I put this? This one. Let's put it here. This function. So again, the slope will be, well, you can see the slope will be 1 over 2. So it's y equal 1 over 2x, right? Because y-intercept is 2. So y-intercept is 0. Alright, so what do we do? Now, let's just go here. So we want, over region 1, we want the x to go from 0 to 1. And we want the y to go from this from here to here. So from 1/2 x to the top function will be 3x. And that would be ex minus y, and that's a dy dx. Plus, over R2, we want the x to go from 1 to 2. But we want the y to go from, again, same one, 1/2 x. But the top will be, see, negative 2x plus 5. Alright, before we finish, we're going to try to finish this integral. But let's just do it the other way around just so you can learn more on the same problem. Alright, so let me do the graph here. So we want 0, 0, 1, 3, and then 2, 1. So again, it's this... so it's this triangle. Again, we have a problem because now on the right side we have two graphs. We have this and that. So the only way to do it is to divide this in two pieces. So I'm going to call this R1, or D1. Let's call it R1, same thing R2. I want to mess up my graph. Alright, so the double integral will be, it's the same region. It's going to be 1 will be equal the sum of two integrals, double integrals over R1 plus double integral over R2. So E x minus y dA over R1 plus over R2, same thing, Ex minus y dA. Now remember, we're going to use type 2, so we want to go from left to the right graph. So we need this equation, which is the same one, except now we need to solve for x. So in our case, this was y equal 3x. Now if we solve for x, it will be x equal 1 over 3y. Now same thing for, if you look at this, if you solve for x, x will be equal y minus 5. Let me write it here. X equal y minus 5 over negative 2. Or, how can I rewrite this easier? So x is equal negative 1/2 y plus 5 over 2. Now for the bottom one, where is the bottom one? Y equal 1/2 x means x equal 2y. So this will be x equal 2y. Alright, so let's do this. So this will be equal... Now for R1, we want the y to go from, now we're starting from y to go from 0 to 1. And then, let me first divide it in two, have same problem. Oh no, yeah, we did already. Yeah, from y goes from 0 to 1, but we want the x to go from here to here. So the x to go from 0 to 2y. And then Ex minus y, but this time not dy dx, dx dy. Plus, we want the y to go from here to here, which is from 1 to 3. And we want the x this time to go from this graph, from this function to this function. In other words, 1 over 3y to negative 1 over 2y plus 5/2. And it's the same thing, Ex minus y, dx, dy. This is dy. Alright. Now, let's do one of them. We're not going to do both integrals, so let's do one of them. So let's do this one. So I'm going to separate Ex. Ex to the minus y is equal Ex e minus y. Right, so that would be equal integral from 0 to 1. Well, let me do it in two steps. 1/2 x, 3x. This will be Ex e negative y dy dx plus 1 over 2. Well, I forgot here, Ex minus y dy dx. So 1/2 x negative 2x plus 5 Ex times e negative y dy dx. Alright, now first you want to do always the inner integral. The good thing is both of them are the same except for the limit of integration. So Ex is considered a constant. I don't do anything to it. But e to the negative y, the integral will be minus, so I'm just going to put the minus here, minus e negative y. And I want this to be between 1/2 x, remember we replace that into y, and 3x dx plus, same thing here, except it's going from 1 to minus ex e negative y, but this is going to be 1/2 x, and the top will be minus 2x plus 5. Alright, let's do more. Now, all I need to do, plug in the 3x into y, so that would be minus ex, it will be e negative 3x minus, plug in 1/2 x into y, e negative 1/2 x dx plus this integral 1/2 minus ex, plug in negative 2x plus 5 into y. That's gonna give us e 2x minus 5. I'm multiplying by negative 1 minus e negative 1/2 x. And this is going to be dx. So let's finish it at the other side. That would be equal to, now all I need to do is distribute. That would be equal integral from 0 to 1 minus e to the x times e to the negative 3x will be e negative 2x. So e negative 2x minus minus is plus, so plus e 1/2 x dx plus integral, and this time is from 1 to 2 negative ex, and well, I need to distribute, so it would be e, let me write it twice. So that was e 2x minus 5 minus e negative 1/2 x dx. Now this is going to be equal, integral from 0 to 1 minus e negative 2x plus e 1/2 x dx. So here I need to distribute minus e x plus 2x will be 3x minus 5. Minus minus is plus. X minus 1/2 x is 1/2 x. Alright, now all I need to do is the integral, which is easy. So that would be 1/2 integral of e to the negative 2x. That's pretty easy. So 1/2 e negative 2x plus 2e 1/2 x, and you want this between 0 and 1. This is plus, and then plus this will be negative 1/3 e 3x minus 5 plus 2e 1/2 x between 0 and 1. Now all we do is plug it in. If you plug it in, it's supposed to get 1/2 e negative 2 plus 2e 1/2 minus 1/2 minus 2 plus negative 1/3e negative 2 plus e 1/2 minus 1/3 e negative 5 plus 2. Now just simplify that, you'll get 1/6 e negative 2, because both of these will be gone, plus 4 e 1/2, because 2 plus, I don't know, where's the other 2? Yeah, this was 2e 1/2. It's good that I've noticed that. Minus 1/3e negative 5. and then these will cancel, and then you'll get minus 1/2. And that's just a number. You can use a calculator. And that's it for this example.